Hey Mustangs, welcome back to another edition of No Here, No Problem. Rosenwald here. We're going to be working on operations with functions in domain, and these are the guided notes. They're little bit long, so if you want to try skipping a couple problems, do them on your own later, come back to them, whatever. There's a lot of writing and color coding. Take the time to make sure that when you do this, you do color code just so you can visually look at what's going on. Pause it, try stuff. It's fairly easy. It's kind of laborious, a little bit of the work. Okay, so let's get started. We're going to be working on function operations, which the three main ones we're going to work on are addition, subtraction, multiplication. And so what we're saying is that when we have two different functions taking place, we're adding them together. And when we're adding them together, it's going to look like f of x, or f plus g of x, which means that we're going to be doing f of x and adding g of x to it. When we look at f minus g of x, the way that we see that is that's f of x minus g of x. So there's just subtracting the two functions that are taking place. And when we have multiplication, we have fg of x, which sometimes you'll see it as fg, sometimes you'll see it as like an f times g of x. So you'll see it as both. What this is implying is that we're going to take the two functions and multiply those together. So what does this look like in operation? Well, if we take these two functions that we have right here, f of x is f of x is equal to 5x, and g of x is equal to x plus 2, well, if we use the definition that f plus g of x is the same as f of x and adding g of x to it. And so if we take f of x from up above, which is right here, and we put it down in the f of x spot, we now replace it with 5x. If we take the g of x that we have up top and we move it down underneath the g of x, we now have x plus 2. And then from here, it's just a matter of combining like terms. The 5x and the x will go together, and we end up with 6x plus 2 for the final answer there. If we do subtraction, it's the exact same process. The difference is that instead of us having a plus in the middle, we're going to have a minus in the middle. Now, this is really important that you recognize that as you're doing this, you'll notice I used parentheses right here, and I used parentheses right here. In addition, it doesn't actually make a difference because adding will never change anything. But in a problem like the subtraction one, the subtraction is really going to make a difference that there's parentheses around it. Let's see what happens. So if I take the f of x and I put it in down below, we still get this 5x. But now when I take the g of x that we have and I put x plus 2 in there, what's going to happen is this minus sign that we see right here is going to have to be distributed. That minus sign is going to be distributed to there, to the x, and it's also going to be distributed to the 2. So it's going to get distributed to both things. The plus wouldn't change anything, but that x with the minus there distributes and it changes a lot. So now we're going to end up with the 5x minus an x and then minus a 2. And again, from here we go ahead and combine like terms, we end up with 4x minus 2. All right. Same thing with multiplication. We have f of x times g of x. So let's replace f of x with that 5x, and let's replace g of x with its x plus 2. And again, what's going to happen here is the parentheses taking place there imply that there's going to be distribution. So this 5x that we have right here is going to be distributed to both the x that's right there, and it's going to be distributed to the 2 that's right there. So it gets distributed to both. And so we end up with a 5x squared and a 10x in the end there. So let's try practicing some of these and see kind of what happens with everything, okay? In number 1, we're asked to take f plus g of x and f minus g of x. And we're going to find what those values are. In addition, later on, we're going to take and we're going to solve for, or we're going to simplify and see what, wrong word, sorry. We're going to evaluate when x is equal to negative 1,000 in these cases. So let's start with this first one here. It's asking us to do f plus g of x. And so what that says is we're going to take f of x and we're going to add g of x to it. So f of x from up above is that 2x minus 3. G of x from up above is x plus 1. Combined like terms, we end up with 3x minus 2. And so that's our first answer that we have over on the right side here. It's 3x minus 2. For f minus g of x, it's the same thing as what was up above, that we're going to take f of x and subtract g of x from it. And so that means we're going to take and replace f of x with 2x minus 3. we'll replace g of x with x plus 1. And again, because we have a minus sign here, that minus gets distributed to everything that comes after it in this problem. So that means that we're going to have that x plus 1 turn into a negative x and a negative 1. Combine the like terms, we end up with an x minus 4. And that's our second answer over here. So now that we know what f plus g of x is and f minus g of x is, we can take that negative 1,000 and substitute those into each one of our equations. In this f plus g, we know that we're going to take the x and replace it with a negative 1,000. So let's take it and put it in for this x that's right here. And what does that look like? Well, we'll go ahead and replace that x with a negative 1,000. And again, anytime we do substitution, we should be using a parentheses with it. Simplify this, we get negative 3,002. Okay? Same thing with the subtraction. This time we're going to take the negative 1,000 and we're looking at the subtraction problem. So it's going to go to the subtraction problem. And in place of our x that we have right here, we're going to go ahead and replace it with a negative 1,000. And simplify that, we get negative 1,004. Okay? So this is an example of one of the problems. The rest of these now are just going to be practice. So feel free to pause, try them, and then come back and check your answers, or you can just continue watching the video and we'll go through each one of these, okay? But having now seen the whole idea of it, you're going to see me go a little bit quicker through these, okay? So first one we're going to be doing for number 2 is we're doing f plus g of x. That's f of x plus g of x. We'll replace f of x with x minus 3. We'll replace g of x with its x squared plus 1. And again, in this problem, that plus, if I distribute it to everything, is not going to make a difference, so I don't have to worry about it. So I can just go ahead and combine like terms. We get x squared plus x minus 2. And that's our answer on that first part over there on the right. Okay, g of x, f minus g of x is going to be f of x minus g of x. We'll take f of x, which is x minus 3. We'll take g of x, which is x squared plus 1. And again, this one, because we have a minus in the middle, that minus gets distributed to everything that's coming after it. So we're going to end up with a negative x squared and a negative 1. Go ahead and combine our like terms. We get negative x squared plus x, and then a minus 4. Okay, so that's our answer for the second part. And then again, for this, we're going to take the negative 1 and we're going to substitute it in for x in the first equation here. It's going to go in this one. And so we'll replace this x and we'll replace this x with the negative 1. And again, anytime we do substitution, we should use a parentheses with it. So that negative 1 squared, and make sure the square goes outside, but it's going to be a negative 1 squared plus negative 1 minus 2, which equates to a negative 2. Okay? Same thing with the f minus g of negative 1. We're going to replace the x with a negative 1, but we're going to do it right here in the second equation. Now this one you got to be very careful with. You have a negative already in the front. And so that negative, it's still going to be part of the problem. So when you do your substitution, put in the negative in the front, and in place of the x that we have up here, we're going to replace this x and then the other x with the negative 1. Put this in our calculator, we simplify, we end up with a negative 6. Okay? All right, number 3. F plus g of x. F of x is 2x squared plus 5x. G of x is 6x minus 1. Combine like terms, we have 2x squared plus 11x minus 1. F minus g of x, take the f of x and replace it with 2x squared plus 5x and g of x with the 6x minus 1. We have a minus here. Remember that the minus distributes, and we end up with a negative 6x and a positive 1 this time, because that negative is going to convert this negative into a positive. Okay? Combine like terms, we end up with 2x squared minus 1x and plus 1. We'll move those over. So the f plus g of x is just 2x squared plus 11x minus 1. For f minus g of 2, we're going to take the 2 and we're going to put it into the second equation here. So we'll have that x replaced with a 2. And then we are going to simplify that and we end up with a positive 7. Okay? Let's continue with number 4. Same thing, f plus g of x. Add them together. Now, this one presents a new problem for us. That x minus 4 squared, that's probably something you haven't seen since freshman algebra. What's going to happen is we are going to look at this x minus 4 squared as an x minus 4 times x minus 4. Now, how do we multiply that out? This is something that we have to review. Multiplying this out requires a process that a lot of people like to use called FOIL. FOIL stands for first, outside, inside, and last. So what does that mean? Well, when we say FOIL, it's a whole process that what we're doing is we're multiplying out in a certain order. So if I was to go through and try to do this order here, let's say I did the, whoa, geez, whew, I don't know what just happened there. A lot of, okay, first. The first means you're going to multiply the first terms here, x times x. And so when we multiply x times x, we're going to get an x squared. Okay? The next thing that we're going to multiply is going to be the outsides. If we multiply the outside values, what's going to happen here is we are going to have the outsides get multiplied, which is going to be these two terms. Those are the outside terms. Okay? The middle terms, the inside terms, when we look at this, the inside are the terms that are literally on the inside. And so when we look at what's on the inside here, the inside terms are these two. Okay? And then the last thing we're going to multiply are going to be the last terms. And the last terms, give me 1 second here. The last terms are going to be the last terms in our numbers here. So the -4 and the -4 getting multiplied together. And negative times a negative is a positive. When we multiply all that out and combine the like terms, we end up with x squared minus 8x plus 16. Let's combine the like terms, and we get x squared minus 3x plus 12. Okay? This is the one we're going to do subtraction. So we have f of x minus g of x. We'll plug this stuff in that we have. 5x minus 4 stays the same, but that x minus 4 squared, we just did it in this previous problem here. Right here, we know that it's x squared minus 8x plus 16, so we just go ahead and replace that with x squared minus 8x plus 16 there. Distribute the negative. There's a lot going on with this negative here. It's going to distribute to everything that's after it here. And so that's going to mean that we're going to have a negative x squared, a positive 8x, and a negative 16. Again, that's just taking and distributing the negative to everything that comes afterwards. Okay? So here, here, and here. Go ahead and combine the like terms. We have negative x squared plus 13x minus 20. So let's go ahead and move that over here. The second question here asks for f plus g of 1. So when we have f plus g of 1, we're going to take that 1 and we're going to plug it into our first equation. So this 1 right here is going to get plugged in right here in place of my x's. So we have 1 squared minus 3 times 1 plus 12, and we end up with a 10. Okay? So that's all the addition and subtraction problems. Let's try to do an application with this. Okay? So in the real world, we have companies that are trying to sell stuff and they're trying to make money and they're trying to maximize their profits, but they have to take into consideration there's a cost involved with doing stuff. You sell stuff for a certain price, but it costs you money to actually do it. So for example, if you ever had a lemonade stand when you were little, if you open up the lemonade stand and it cost $10, but you sell $15, well, it cost you 10, you sold 15, so 15 minus 10 means that you made $5. That making of money is called revenue. That's how much money we're actually generating. And so when we look at this problem here, it says that we have a company with a textbook. Their cost to make it is 0.2x squared plus 10. They're selling the product for 0.05x squared plus 20. So then when we look at the way to make money, it's taking the price of it that they're selling it for and subtracting the cost from it. And so that looks like this, P of x minus C of x. We'll replace the values that we had. There's your P of x and there's your C of x, and we're subtracting the two. Combine our like terms, we end up with distributing the negative, and then combining the like terms, we end up with 0.03x squared plus 10. So for part B, it says, explain what P minus C of x represents. And I just said it. This is your revenue. This is the money that actually gets generated from you selling the textbooks. Your revenue is always how much you are able to sell it for minus the cost it was required to make it or to sell it. Okay? All right, next, we're going to jump into multiplication. And this is going to require a little bit of review again with FOIL. So first, multiplication, it's the exact same thing as what we did before. It's instead of addition and subtraction, now we're doing multiplication. And so we're going to multiply these two together. So that's f of x times g of x. When we multiply these out, we're going to go through doing the whole FOIL process, okay? And foiling, I just erased something on accident there. When we go through and FOIL, let's do the first. 5x times x. 5x times x, that's your first terms. That's going to give me a 5x squared. The outside terms, FOIL, so outside terms, 5x times 3 is going to give me 5x times 3, which is 15x. Negative 7 times x, that's our inside terms. Negative 7 times x will give us a negative 7x. And then the last terms is the negative 7 and the positive 3, which will give me a negative 21. Put your like terms together. We have 5x squared plus 8x minus 21. So we get 5x squared plus 8x minus 21. They say, let's evaluate this when x is negative 5. So we're going to take our x, and in place of x, we're going to go ahead and put what x is now equal to, which is going to be negative 5. And then simplify this with your calculator. We end up with 64 for the overall answer there. Okay, sorry, my throat's a little dry. All right, next one. Same thing, multiplication. Replace f of x and g of x with what they're equal to, so 12x times 11x minus 1. We will go ahead and distribute here. So if we distribute, 12x times 11x is going to give us a 132x squared. Distribute this times the negative 1, we end up with a negative 12x. Neither of these are like terms, so they're not going to combine, so we're done. It's just 132x squared minus 12x. We're going to take our x and replace it with a 4 here and a 4 here, and we end up with this. Throw this into a calculator, we get 2,064. All right, last one for the multiplication. So again, multiplication implies we're multiplying f of x times g of x. So replace f of x with x squared plus 8, g of x with 2x minus 3. Let's go through and FOIL again. So if we're going to FOIL, the first terms, which is the first terms right here, multiply these two together. X squared times 2x is 2x cubed. We're going to multiply the outside terms. So there's your 2 on the outside of it. Multiply these together, we get negative 3x squared. Your inside terms, positive 8 times 2x is going to be 16x. And then your last terms, your last in each section is going to be negative 24. Put your like terms together, and in this case there are none, so we're done. We just copy it all down and everything stays exactly as it was. So we'll put that in here, and this time again we're going to replace x with 6. So in place of this, we're going to put a 6 for each one of these x's in this problem. And we end up with 2 times x, 6x to the third, minus 3 times 6 squared, plus 16 times 6, minus 24. And that whole thing ends up equaling 396 when you put that into the calculator. Okay? All right, we're almost out of the woods here. This problem, we're asked to look at a graph and figure out which one of these graphs down below is f plus g of x, and which one down below is f minus g of x. So we have two different equations going on here. We have f plus g and f minus g. Let's just start and see what happens. If we do f plus g, we're going to take our two functions that we see here, which this is my f of x and this is my g of x, and we're going to add them together. So f of x plus g of x, we'll replace f of x and g of x with their functions, what they actually equal. We'll go ahead and combine like terms, and we end up with x squared minus 1. So that tells us conclusively that part B down below there, that is our f plus g, which means the other one is our f minus g. Okay? All right, down below, reviewing real quick, solve for x, given the equations y is equal to 3x minus 5 and y is equal to 25. Here's the deal. These are ones where people are so in the habit now of just putting in the number for x, putting in the number for x like we've been doing. Well, what about when we don't have a value for x and they're asking us to solve for x? Well, for solving for x, if I know that y is equal to 25, I could take that y and put it right here in place of this y, because they're the same thing. So if I know that y is 25 and I replace it, this is what we end up with. 25 is equal to 3x minus 5. Go through your steps for solving an equation now. We'll take this negative 5 and move it by adding 5. We'll then take this 3 and move it by dividing by 3. And we now know that x is equal to 10. This is what we've done in the past. This is nothing new. Well, the new notation looks like this. That remember we said that instead of using a y, we're using f of x. And if I tell you that f of x is equal to 25, and I'm asking you to solve for x, let's take f of x and replace it over here. And so we know that f of x is 25. That's going to look like this. The same thing. It's the exact same thing as the problem we just did. So nothing changes. It's just the way that the notation looks, because instead of a y, we're using f of x. So let's try a couple of these problems. We know in this one that f of x is equal to 31, so let's replace this f of x with 31. That 7 minus 2x just comes down. So now we're going to go ahead and try to solve this. Now most of you are going to say 7 minus 2, you're going to subtract right away, but you don't do that. This 7 has to go away first. So it's a positive 7. In order to move that 7, we're going to take away 7 from both sides. And if I take away 7 from both sides, it goes away from the right side there. And the left side now has a 24. This negative 2, we have to divide by negative 2 to get rid of it. So that we'll get a negative 12 is equal to x. Go to number 9. And I would actually recommend trying to pause these and see if you could do these last two on your own. But f of x is equal to 11. We're going to replace f of x right here with an 11. So we get 11 and x plus 5 over 2. When we're dealing with fractions, how do we get rid of that divide by 2? Well, the inverse of dividing by 2 is to multiply both sides by 2. That gets rid of the 2 that's right there. So when we do this, we end up with 22 is equal to x plus 5. Move the 5 over by subtracting 5, and we end up with 17 is equal to x. Last question, number 10. F of x is equal to 27. We'll replace this. We get 27 is equal to 3 times x minus 1. Let's distribute the 3. So we end up with 3x minus 3. We'll move this minus 3 over by adding 3 to both sides. So we end up with 30 is equal to 3x. We'll divide by 3 on both sides in order to get that x by itself, and we end up with x is equal to 10. That's it. So now that we've completed the notes, use this to kind of guide you through practicing these skills. And just remember to submit these online. Again, thank you for watching. Don't forget to like and subscribe. You take care, Mustangs. Have a great and safe day.